Hi everyone. Today we'll discuss polymorphism. So, in the previous 3 to 4 lectures, we have discussed inheritance in detail. Now we'll discuss polymorphism, right? So, polymorphism means one thing and many forms, right? And it's really important feature in C++, right? Not in C++, basically polymorphism is a feature of every object-oriented programming language that I know. And for C++, I can say polymorphism is a feature in C++ by which one thing can perform many functions. For example, if I take analogy of real life, a girl performs a role of sister, mother, daughter, wife, etc. So that's the concept that one thing should perform many roles, right? There are two types of polymorphism in C++. There are two types of polymorphism in C++. The first one is compile time. The first one is compile time, and the second one is runtime, right? And the second one is runtime. So let's discuss about the compile time polymorphism first, and after that we move to the runtime polymorphism. Okay. So compile time polymorphism is further divided into two parts. Means there are two ways by which you can perform compile time polymorphism. The first one is function overloading, and the second one is operator overloading, right? So in compile time polymorphism, or you can say a compile time polymorphism is a polymorphism, right? Means at the compilation time, the compiler knows that some multiple things are involved in this, or multiple functions with same names are here, right? Let's discuss function overloading, right? Function overloading is a feature by which one class can have multiple functions, you know multiple functions but with the same name, right? So multiple functions, but of course with the same name, of course, right? Multiple functions with the same name, and with same name, then how the compiler or runtime will make difference with different parameters, of course, right? With different parameters. Multiple functions same name with different parameters. For example, I have two functions, basically abc. This is one function, and the second function is abc, and here I am inputting there is one parameter, right? So this thing, particularly this thing, is allowed, that will be counted as the function overloading. And let's see a practical implementation of this before moving forward, right? So let's move to the compiler and see. Yeah, so let's say there is a class called, what should be the name of the class, right? Let's say we have a class. The class is some software like e-com software, or you can say, so you can say there is an e-commerce software, right? And it's public, right? And let's make it public. So here we have show result, right? The user, basically the user will enter the details about the product, maybe a search keyword or the category, right? So in the show result, we have string, the search query. Using the search query, we have to show the result. based on search query. Now we have, the thing is, if there are filters, what we would do, should we, and there are 10 filters, the user has given the flexibility to enter 0 to up to 10 filters, right? So what should we do? We should create another function like filter, or we should create the same name with different arguments. I guess this is better. Search query and string filter one, like, or you can say string category if the user has entered only category, right? But if the user has entered a subcategory as well, then there should be an appropriate function for that, right? Subcategory. And if that's the case, here you can say that, you can see that we have 3 functions with same name, but every time with a different parameter. Here we have 1 parameter, here we have 2 parameters, and here we have 3 parameters. And in C++, oops, it's allowed. It is called function overloading and is a part of compile time polymorphism, as we have discussed, right? So based on query and category, based on query, category and subcategory, right? And let's say we have an e-commerce software, and the name of the e-commerce software is any, say, means anything, you can say easy buy or easy buy, right? The name of the e-commerce software is easy buy. So easy buy dot show result, we have given strings like anything, you can say these are dummy strings as such, right? What will happen is, will it show a compiler error or no? Okay, it's not Java, it's C++. Right, let's see now. See, we have shown the result based on query, category and subcategory, and now see, just a minute, let's put an end line here. Okay, I forgot the Java. Right, and let's see. So it's based on, we have encountered 3 functions based on the category, based on the search query, query and category, query, category and subcategory. So that's how the the polymorphism works, right? So that's the thing, and let's move forward with function overloading. Let's see operator overloading. So that's going to be, it was initiated, it's also simple basically. Operator overloading works in, it's, you can say, an important concept in OOPS, but not that means personally I haven't used that much operator overloading, but it's better to understand, because not much it is not very much used, but sometimes it is, yeah, you can say it is used, right? And in Python, overloading is heavily used because uh, in Python, string is a class and you can add the strings using plus, and there plus is an overloaded operator, right? So to understand it, it's really important, right? So so operator overloading is like, there are different operators like plus. Let's take another, yeah, there are different operators like plus, minus, multiply, divide. So we can operate all of these operators, right? And there are some limitations. There are some operators which cannot be overloaded. There are some keywords also, right? So the scope resolution operator, like, let me write for you, right? We'll see later, right? We'll see later. So let's see a practical implementation, right? Here we have a operator overloading, right? This is the main function, and let's say we have a class which is number, right? And the number is public, and I'm using the concept of, right, why it's private, because as a developer, I personally don't want to anyone to touch this number directly or indirectly. They should interact with our data members through the functions that we have provided. So we are in basically control of who can access our data members, who can have the rights to mess up and everything like this, right? And let's create, okay, this is a keyword. Operator is a keyword. This is our class name, and which operator we want to overload, like this. And this is basically a kind of syntax that for now you can say that uh, you can memorize it, or like this, right? So so basically, if we want to understand this, it's pretty much simpler, but anyway, right? And that's it. Basically what we are doing is, it's like declaring a function only. So here plus is the function, and here object is the argument. The object of type number, which is const, is private, is the argument. And basically what we are trying to do, we are trying to add this number with the data member of this object, and after that we are adding it and just returning the result, which is this object, which is the temporary object, right? So let's see. So we have a number, num1 which is equal right, and let's create a constructor here. Now I'm trying to fuse different concepts here, right? Overloading, access modifiers, constructors and all that, right? And it should be parameterized constructor, right? This keyword is used, and number num1, and the number should be 10. So here num1 is the object, and basically this, for this object, this plus operator, this basically plus operator will act as a function here. Parameter is num2 here. This dot num of num1 will be added with the number of num2, and the result will be returned, and let's see if what is the result, right? And there should be another function like display, and the display is okay. What's the error? Okay, so if you can notice, I have made the object of this class, I have made only parameterized constructor. I haven't made any default constructor. But wait, default constructor is automatically, if it's not there, it's automatically created by the compile time and supplied to the runtime. Condition applied only if there is no parameterized constructor. If there is a parameterized constructor, the compiler will assume that there is a parameterized constructor and the developer don't want to create a default constructor by himself, right? And that's the thing. So it's our job to create the default constructor if in case we want to create an object without any parameters or something, without any arguments, right? And let's see, yeah, so that's it. See, the num1 is 10 and 12 and the num2 is 7. When we added, we returned the object result, and the object result is then stored in the num3, and we have output, the output of num3.display should be 22 and is 22, right? So that's the thing. If I should explain you again, right, we created class number, we have created the num as private, and we created a default constructor, we created a constructor with parameters, and number dot operator, basically this is kind of the return type. Now this is the return type, and this is just to signify to the compiler that what we are overloading is a operator, not a normal function, right? And in the function argument we have another object. We are just adding the two numbers and just returning the result as an object only, right? And we created two numbers, number 1 and number 2, as 10 and 12, and we are just invoking this plus function here, and the output, the result output, which is the object, is stored in the num3, and we are invoking the function display. With the output of this function display is that number, right? And that's it. And if I could run it again, it's 22, right? So these are the things, and let's move forward. Yeah, so there are some things which we cannot overload. There are some operators or keywords that we cannot overload. The first one is size of, we can't overload it, right? The second one is type ID. The third one is like ternary operator, you can say ternary operator, right? And the fourth one is access operators. class member access operators. The access operators like dot operator, it's not allowed, and the pointer to member operator, basically this operator is also not allowed. Pointer to member operator, right? Also scope resolution. I guess we'll see the scope resolution, right? But these are the operators which cannot be overloaded, right? And the size of, type ID, ternary, and scope resolution, right? And the operators which are allowed to overload are basically unary, binary, and special operators, but these are the exceptions. You can take these as exceptions, and the things which are allowed operators which are allowed, just a minute, what's happening here? Yeah, the operators which are allowed are unary operator, binary operator, and the special operator, right? Obviously these are allowed, but from here these are the exceptions, right? And binary operator, unary of all are allowed, right? So that's the thing. Let's move. This is all in the uh, overloading, operator overloading. If I want to create it as separate, right, this is overloading. And let's see if the runtime polymorphism. The runtime polymorphism is actually which is resolved at the runtime, right? For example, you can see one more thing that I left is the runtime is called late binding, and the compile time is called early binding, because runtime is resolved at the runtime and the compile time is resolved at the compile time, right? So the runtime is achieved through function overriding, and function overriding is achieved through an inheritance. Inheritance is involved in runtime polymorph. So function overriding is like, suppose we have a parent class and it has a member function, and in the child class also has this member function of the same name, same parameters, right? So to resolve that means, let me show you. Let's say here is a class. The class has a member function like ABC, right? And in the child class also has the method ABC, and we have explicitly declared here, right? So if you can carefully observe, this ABC will be virtually present in the child class. So here the function overriding takes place. So how to solve how this problem will be solved? To practically understand it, let's see a program, and here we include our header files. And let's say we have a class like, any class, any damn class, you can say public void print. Now void display, or So it's the base class, right? This is the derived class, and so that's the thing. And this is this is the runtime polymorphism. All the things will be resolved at the runtime only, not at the compile time, right? And let's say we created an object of derived class, derived, and uh, derived will try to access the function display. So let's see which function this derived will refer to this display or this display, right? Let's see. Okay, okay, it's a class, it's not a function, right? Yeah, so it will take reference from the derived class, not from the base class. So basically here this function is virtually present in the child class. This function is virtually present here and the child class, but the object will take reference from the, if the object is from the base class, then it will take reference from the base class. If it's taking reference from the child class, it will take reference from the child class, right? This is base class, this is child class, right? To generalize, we can say that the function of a particular class will take reference from that class only, right? Not from his parent class, not from his child class, right? And this is function overriding. This is achieved at the runtime, and this is the whole. If I were to separate it from you, this whole journey is separated. This whole journey is further separated, right? This is function overloading, this is function overriding, and this is operator overloading. I guess you are able to understand it, right? Basically, if you're finding it overwhelming, then don't worry, you're not alone. You can ask, you should ask the doubts. Basically, I am expecting some doubts, right? And you should actually analyze all the case studies that I have mentioned in the inheritance. Will that case be function overriding? For example, let's not mess up here. For example, if there is a function, if there is a class here, we make, if there is a class here, we create two classes. Now here, if I take object of this class, will it refer to this class or this class or this class? Obviously, now I guess you know that the object of this class will take reference from this class only. Try to create as many case studies you want as possible, or just play with it, right? Play with the concepts and ask me. You may be right, you may be wrong, but when your doubt is clear, your concept will be much stronger. And the thing is, let me tell you a secret. In all the programming languages, let me type it because it's important. In all programming languages, concept only same, and only syntax changes. right? This is the golden statement. You should focus on the concepts. The syntax can be learned, right? There are plenty of tutorials out there. My job here means I'll try to make a concept as strong as possible, so that you don't have to, you know, you don't have to go to something to understand the syntax, because documentation is obviously available, right? To understand the concepts is much important than the syntax. So since these all code, this is function overloading, this is operator overloading, and this function overriding, all these three will be available, right? And the notes also, the reference material will also be available. Check out those, make more case studies. If you have any doubts, then just ask us. And i I also encourage you to solve the problems of your peers also, right? If they are challenging enough, then you should be attracted to those.